Hey guys, welcome back to Python 101. And today is a very special occasion because we're on week 20. Yay! Okay, so first things first, I want to thank everyone for supporting me and getting me this far. Without your support, I would have been stuck at week 5. But still, thank you and please share. Let's get started. So, last time we started talking about advanced OOP. And now we're going to keep talking about it. Now, why do we use self? So in class, we use self a lot. And, well, Python uses self to find the right set of attributes and methods to apply to an object. So when we want to say tcma.recharge from the previous example of cars and, Elon Musk and stuff, oh, by the way, SpaceX launched their rocket today. I watched it. It was pretty fun. And so, anyway, let's keep on going. What really happens is that Python first looks up the class belonging to TCMA hybrid and then passes to hybrid.recharge method. It's the same thing as running hybrid.recharge TCMA, but here our thing is shorter and more intuitive. So basically, if you don't understand that, just the main gist is use self. It's good for yourself. Anyway, now we're going to talk about something new called Method Resolution Order, also known as MRO. Things get complicated when you have several base classes and levels of inheritance. This is resolved using Method Resolution Order, a formal plan that Python follows when running object methods. To illustrate, so if classes B and C, so we're going to create a main class A, which is at the top, and then B and C will both derive from A. And then the last class we're going to make is D, which derives from both B and C, meaning that D will be at the bottom of the inheritance. So let's call it P101, week 20, part 1. All right, let's get started. Class. We're going to create the main class called A. We're going to num is going to equal to 4. Next, we're going to create a class called B. And it's going to inherit from A. And then we're going to pass. We're not going to do anything. We're going to do the same thing for class C because class C inherits from A. But here we're going to do number is going to equal to 5. Next up, last but not least, class D. And then here it's going to inherit from both B and C. And then here we're gonna pass. So it does nothing at first, but what if we were to do d dot num? What do you think is gonna happen? You just write your answer down and then we'll discuss it. Well, we won't discuss it, but all right, so I'll assume you gave a go at it, and let me show you. So it's 5, and we can see that. Let me give you a visual example about how this works. So the top class is A, and then the number is 4. It goes to, and then class B and C both inherit from A. But here it's just a pass, so really nothing happens. But here the number is equal to 5. Yes, here we go. And finally, they will both be inherited by D, which is a pass. Now, let's think about it. If you want to find D, and D was equal to 10, then this would be equal to 10, then this would give you a 10. But right now it's a pass, so it's kind of like a null thing. It doesn't give you anything. So let's see, it inherits from both B and C. Now, B has a pass, meaning that it doesn't have anything, but C has a 5, meaning that D inherits from a C because B doesn't have anything. That's why it gives you 5. You would think that d.num would follow B up to A and return 4, but instead Python obeys the first method in the chain that defines num. The order followed is D, B, C, A, and then object, where object is kind of like the Python's base object class. For example, the first class to define and or derive previously from is C, so it's 5. So make sure you, I hope you guys understand it from a visual point, and I'm going to erase that. So next up, we're going to talk about super, this function called super. Superman, Python's built-in super function provides a shortcut for calling base classes because it automatically follows method resolution order. In its simplest form with single inheritance, super can be used in place of the base class name. In a more dynamic form with multiple inheritance like diamond diagram, which is what we did, super can be used to properly manage method definition. So let's go back to the Jupyter Notebook and create a class called my base class, and I'm going to do it in camel case. Now I'm going to define double underscore. Remember, there's double underscore init, double underscore, and then self x and then y. Now we're going to do self dot x equals x, and then self dot y equals y. You know, the regular stuff. Now we're going to create another class called my derived class. Now we're gonna inherit from my base autocomplete. There we go, autocomplete. Now we're gonna define double underscore init, double underscore, and then self, and then x, y, z, x, y, z. And then because we already defined x, y, we can just super, we super, and then we do dot double underscore init, double underscore x, y. So I'll explain that part later, and then self, because we already explained x and y, now we can just do self dot z equals z. Oops. My base, I wrote class. There we go. So note that we won't pass self to super.init as super handles that automatically. So that's very super. All right, so as you can see, super just handles the self automatically, so you don't need to do it. Well, opposed to our example last week. Yeah, so it just kind of replaces part of the self. Next up, we're gonna do another class called A. We're gonna define truth and self. We're gonna return, let's see, all these numbers are even. And then here we're gonna create a class B that inherits from A, and it's gonna say pass because I don't want it to do anything yet. And class C is gonna inherit from A, and it's gonna define truth self. We're gonna return, let's see, some D. All right. Now we're gonna do class D, and then we're gonna inherit from BC. So it's kind of like the diamond I did in this one, but here we're gonna be a little bit more sophisticated. I'm gonna define truth, and then we're gonna do self, and then a number, okay? And then we're gonna do if number is mod 2 is equal to 0, return, we're gonna return a dot truth in self. So basically, if any number is divisible by 2, then we're gonna return all these numbers are even. Next up, if we do else, we're gonna return super dot truth. Now we're gonna try to use it in D equals D, and then I'm gonna do D dot truth 6. What? Name. Oh, I spelled, wait, num. I spelled num wrong. Okay, all these numbers are even, but what about 7? Some of these numbers are even. So basically what it does, the super, it basically just, so basically if we pass an even number into D dot truth, we'll believe the A version of dot truth and run it. Otherwise, we will follow the MRO and return to the more general case. So it's kind of like an if-else thingy, well, but more complicated. And that's why programming is hard. Okay. So that's it for today. I hope you learned something. And if you didn't, it's okay. It's okay. So one last thing. I'm gonna copy Joe Biden. Okay, I'm gonna be like, wait, no, what was his name? Anyway, once again, I'm asking for your support. Once again, I'm asking for your support. Once again, I'm asking for your support. Anyway, whoever said that, just message me, whoever said that, and I will be asking for your support again. And here we are. So you know what I'm asking. Go to youtube.com, search up, hold on, my internet's terrible. See, this is why I need better internet. And if you guys help me, I can do it. So, you just have to type Featuremania. And here I am, 55 subs. And just subscribe, the red button that's supposed to be here. And all you have to do is press on it. So it's gonna be this red button that kind of appears over here. And all you have to do is click on it and you'll be supporting me. Thank you very much. And I'll see you next time. See ya.